Okay, so we've talked about solving equations. Today I want to look at, and we did a little bit with like perimeter problems and stuff like that. If we know the perimeter, the length is twice the width or whatever, and the perimeter is a certain number, how do we solve it? Well, today we want to look at problems that deal with mixtures. The perimeter, we had that formula that the perimeter is equal to 2 times the length plus 2 times the width. When we're talking about mixtures, and more specifically solution concentrations, what we want to look at is the amount of a substance in a solution. And the amount of a substance in that solution deals with the volume of the solution and the concentration. In fact, the amount is equal to the concentration. Concentration is just the decimal of a percent times the volume of the solution. For example, let's say you had 800 milliliters of a 15% solution. Now I'm assuming this is like something in water, like salt in water or alcohol in water or something like that. So the substance is the salt and the water is just the filler here. So how much of that substance do you have? Well, 0.15, that's your 15% written as a decimal, times 800 is going to give us 120 milliliters. So that's the amount of substance that's in that solution. So as a general rule in anything, the amount that goes in, we'll call that the input, has to equal the output. So what we're dealing with in our mixture problems is we're taking two solutions of different concentrations, and we're figuring out what's coming out the other end. For example, let's say I have 400 milliliters of a 15% solution and 800 milliliters of a 30% solution. And I want to know what I get on the other end. What is, find the percent after we mix them. Well, I have 0.15 times the 400 milliliters. That's the amount of substance in that one. Plus 0.30, that's the 30%, times 800 milliliters. That's the amount of substance in the 30% solution. That's going to give us a certain percent. I'm going to call that X because we don't know what it is, times how much total solution is going to be over here. Well, 400 plus 800 or 1,200 milliliters. Make sense? So over here, 0.15 times 400 is 60. 0.3 times 800 is 240. This is going to be 4 plus 8 is 1,200x. So 60 plus 240 is 30. What are we going to do with that? Divide by 1,200. We're going to get 0.25 equals x. In other words, the new solution, after we mix them, is 25%. Make sense? So now what we're going to look at is what if we do it a little bit differently? What if we ask, oh, let's do this. So we have 18% solution and 27% solution. And I ask how much 18% solution to mix with 360 milliliters of 27% solution to get a 21% solution. So we're going to set this up the same way. We're combining the 18% with the 27% to get a result that is 21%. So the amount of substance in the 18% solution is a concentration of 0.18 times, do we know how much? That's kind of what we're looking for, isn't it? Is the amount of the 18%, right? So that's going to be our x. Plus 27% will be 0.27. Do we know how much of that?
Oh, yeah.
360 equals, on the other side, we're going to have 21%, 0.21. Now up here, why did we have 400 and 800 here? Because we had 400 and 800 milliliters, right? So down here, how much of that 21% are we going to have? Plus x, right? X plus 360. The total volume of the other two added together. So now we got to solve this equation. This is just 0.18x plus, well, 0.27 times 360 is 97.2. 0.21 times x is 0.21x. 0.21 times 360. $75.6. So now we need to get rid of one of the x's. I'm going to get rid of the 0.18x. So I have 97.2 equals 0.03x plus 75.6. And then subtract 75.6. So we got 0.03x equals 21.6, right?
Yep.
And then divide by 0.03. X equals 720 milliliters. Okay, so that's what the mixture problems. The other things we want to look at today is we want to look at dealing with these variables in other ways. For example, in electronics, you guys have that equation, of course, that voltage is equal to current times resistance. You may have seen that one once or twice before, right? So let's say you know your voltage, and we're just going to go with a theoretical voltage. I know that most cars actually run at 13.6 or 13.8 volts or 13.4, whatever you're looking at. But we're going to go with the 12 volt theoretical voltage. What's that? 12.6 is what you guys always figured? Yeah, we're going to go with 12 because it's easier and I'm lazy. And let's say you know you have a resistance of 4 ohms and you want to know what current's going to flow. Now I realize 4 ohms is a low resistance too. How do you find the current? You plug in the numbers. 12 for the voltage, 4 for the resistance, and what are you going to do? Divide by 4. The current is 3, so 3 amps are flowing. Well, if you're going to do this once like this, that's fine. But if you're going to do that calculation a lot, where you have a lot of voltages and a lot of resistances you're going to measure and calculate the theoretical current, you would want to rearrange that formula. You would want to have the I, the current, all by itself and the voltage and resistance on the other side. So I would do this. I would divide this by R. That's going to cancel out the R. What's V divided by R? Well, trick question. It's just V divided by R. In fact, we'll use the connection between fractions and division to just turn it into a fraction of V over R. So there's our fraction there. We might have your velocity is equal to a distance divided by a time. And let's say I want to know the distance. So solve for D. Just like if there's numbers here, what's keeping D from being by itself here? T. What operation is used to attach the T to the D? It's divided. So how do we get rid of it? You would multiply by T. What's V times T? VT. Right? So D equals VT. So the distance is velocity times time. VT go home. You might have a formula like this. And you're asked to solve for X. So here's X. What do you have to do to solve for X? Well, think of this as like 3x plus 7 equals 23. you're going to have to subtract the b first. So that's gone, leaving us with ax. What's b minus, or what's c minus b? C minus b. Now what do we have to do? Divide by a, right? And again, we're just going to use that fraction and division connection to realize that's just c minus b over a. And that's it. Real tough? So on page 264, exercise 6.6, 1 through 25, the odds of those mixture problems. I recommend you try a couple of those at least, because there will be one on your test coming up that most people usually struggle with. On page 267, I think so too. Exercise 6.7, 1 through 19, the odds. And also page 270.